All right, everybody look at page 150. Everybody should have it. So on the back of page 149. Everybody got it? Who did not finish? Who did not finish it? Who has it finished? Raise your hand if you have it finished. Have it finished. It is finished. I thought you just raised your hand. It wasn't finished. Who has it finished? 150. Who has it finished? It is finished. You have finished it. Oh, okay, good. Okay, number 1. So you're just, with a pencil, you're just, be honest at the end and you're going to tell me who made 100. Number 1. Who showed work on number 1? If you don't have work on this problem, you're still not playing to win. And you know what somebody last period had the gall to tell me why they didn't show work? They had the gall to say that loud. You know what they said? I have a calculator. What do you think my eyes did when they said that? My eyes. No. My eyes started popping. That is the worst thing that they could have said. Well, I had a calculator. I didn't need to show work. Buddy. Does somebody have Emily's paper? No. Okay, number 1. Hey. Everybody should have come over here and done an H chart. Everybody should have an H chart. You had these in elementary school, except it had like the first row was so many cans, the second row was so many cans, and so on. So this is 3 minutes is 8:55. 10 minutes is 7:50. The 3 and the 10, what do they represent? The minutes, thank you. And the Y represents the millimeters of sand. Okay, so we're trying to find the equation for it. So what is, to find the slope, we're going to do the change in Y over change in X. What's the change here? Minus 105, thank you. And this is going to be plus 7. So what am I going to come over here to write? Negative 105 over 7 equals, nope, negative 15. So negative 15x is what I go put over there for my expression. Negative 15 times 3 is what? Negative 45. So I'm going to have to add a whole bunch to get to 855. Okay? So how would I get 900 other than look over here? 855 minus negative 45. Good. Did it work? Everybody that did it on the calculator, it worked. Okay, so negative 15 times 10 plus 900. Is that 750? Yes. So that's going to be C. Who got that right? Good. With work. Because if there's no work there, you wouldn't have gotten it right. Been an XW. Okay, number 2. Guys, which one shows linear? B. And all you had to do was draw me a line. Well, just draw a line. Huh? Well, yeah, you could, yeah. But, guys, just draw a line there. Okay, number 3. We've got to find the slope and the y-intercept. The first thing I noticed that all the slopes are in decimals. Now, Miss Kent and I have been preaching, put it in fraction, because if you graph it, you need a fraction. Okay? But now that you've learned how to do slope, you need to know that sometimes you can put it in decimal form if you're not graphing. But I wanted to make sure you knew fraction, because of the graphing aspect. So now, to get the slope, changing y over changing x. And I want you to write it, because some people hadn't learned that yet. Changing y over changing x. So what happens to the y's right there? 500. What? The x's? No. 10,000, huh? So what am I going to write? No. Well, let's not say it wrong. That confuses people. Please, let's think about what we're saying, because then that confuses people when you say the wrong thing. Okay, so when I go divide that, since I need a decimal, I'm going to go divide it. It's going to be 0.05. If I were to put it in fraction form, look, cross out the zeros, and when I when I reduce that, I get 1 over 20. Okay, so I know it can't be B or D. I'm going to come down here and make me an H chart right here. So I'm going to put 0.05x, 10,000. I know they don't give us much room, but you just have to do what you do. So 0.05 times, and I'm going to write it below it, times 10,000 is what? 0.05. You've got a calculator. 0.05 times 10,000. 500. Thank you. Everybody do it. I see people that haven't touched your calculator yet. Oh, one day. Oh, man. One day. Y'all, I'm just going to get up and start taking them up. Yeah, and it's not going to be good. Plus what gives me 2,500? Good. So, it's going to be C. Number 4 is easy also. They gave us the hours in the gallons. So what we're going to do is come down here. We're not going to do what we did in elementary and count all the way down to 14. That's silly. We're not going to go all the way down to 14. Okay? We're going to write our expression because it is super, super easy. Super easy. What happens right here? This is my X, this is my Y. What does it go up? 1.5. What does this go up? So 1.5x, 1.5 times 2 equals 3. And I got to get to 5. So what am I going to add? Plus 2. Guys, if you don't have any work for this, you better have some by the time you finish. Or we finish. 1.5 times 3 is... No. 1.5 times 3. Plus 2, does that give you 6.5? Yes. So now we're going to do 14. Now that we know the expression, we're going to substitute 14 in for x. So 1.5 times 14 plus 2. Now, guys, your book has a spot for the plus or minus. Even though it's a plus 23, you don't really have to do the plus. But remember what I've told you? If you don't do the negative when it's negative, you're going to miss it. So you might as well go do and get used to doing the sign. That's what I would do. Okay. Raise your hand. Now, this means you did work and got it right. If you didn't have any work, it's not right. Who made 100? 1, 2, good. 1, 2, 3, 400. Good. All right. Put that in practice, please. Turn to page 394 in your book. We're going to change gears and do something easy today. Simple, simple, simple. And I promise you it is. Well, all this that we've been doing is simple to me, but 394. And there's other people that's been simple too. We got people in here with 90-something averages. I appreciate you. You've learned how to do it and worked hard. 394. Page 394. Page 394. Okay. Some of these, the graphs they did, I'm not really crazy about, but there's a couple of good ones. Okay, so let's look at this. We are going to do scatter plots. When you're doing a scatter plot, it's a graph that has plots on it, and they're scattered all over the place. Some in them, some have a relationship, some do not. Okay, God bless you. So what we're going to do is compare data. When you do a scatter plot, you're comparing data to see if one affects the other. For instance, how many of you, okay, if I was seeing how old you are and how many pets, do you think there's a relationship between your age and how many pets you own? Oh. Who has 0 pets? No pets at all. Okay. You and I have no pets. How old are you? And I'm 57. So no pets. We have different age, you see? So how old you are has nothing to do with how many pets you own. Right? None. So there's no relationship between the two. But we're going to see some graphs in here that there is a relationship between the two. Scientists do these kind of surveys and to see if there's associations or relationships between, let's say, how many packs of cigarettes you smoke and how many people have lung cancer. Do you think there's a relationship between that? How many packs of cigarettes you smoke and how many people have lung cancer? I would say there would be association. Okay? All right? So look at this first one. This is Joyce. She's training for a 10K run. It wants us to look, okay, what it did was graphed her distance, how many miles she ran, and her time. What do you notice about the points? They're not linear, but are they basically going up? Yes, it's a positive. So this is a positive trend, or relationship, or association. They call it 3 different things. No, on 394, page 394. Because the more miles she runs, the longer it's going to take her. That's a no-brainer to me. So that's what I'm saying. I'm not crazy about this graph, but it is what it is. So, but this line that they drew is called a trend line. That means they just took a line and tried to go down the center where there's the same number of points on either side of the line. So there's 1 point on the line. There's 1, 2, 3, 4 above it and 4 below it. Y'all see that? And then it wants to know for 4.5 miles, about how many minutes is that going to take her to run? Right here, 45 minutes. So we use the trend line to answer or to make a prediction. Okay, at the bottom. What do you notice? This is Bob, his age, and how tall he gets. Well, that's a no-brainer too. The older you get, the taller you're going to get. The older you are, the taller you're going to get. And this one is positive. Circle positive over there. Don't have to write it. They've written it. And it's basically linear because it's almost a straight line. Look, we can line up our ID. It's just a little bit off. 1 point's a little bit off. So he's basically growing about the same every year. So many inches. Okay? 395. Look at page 395. What I need you to do right now, oh, they messed up on this graph. You see where they started at 50? They shouldn't have done that. What they should have done was put like a break in here, like a little break in. There's 2 more graphs that have breaks, and I'll talk to you more about it then. But they should have done a break because that's supposed to be a 0 right there. So, but what I need you to do is take this information from the table and put it on the this graph. Go. Go. Um, Everything's okay, right? Okay. Oh, I didn't pause it. I should have paused it. Okay, 0 is 75. A half is 80. 1 is 80. Oh, wait. I did. Yeah, 1, I did right. Okay, and then 1.5 is 85. Oh, I did 90. 0.75. Half is 80. I did that one wrong. That's not supposed to be there. 1 is, 80 and 85. That one's wrong. Sorry. And then 1.5 is 85 and 95. 2 is 90. Y'all help me. 2.5. No. Okay, 3 is, and 4 is 90. Okay, so do you see a point that's kind of out by itself? No, this one right here. The 490. This is called an outlier. It lies outside the other data. And then what we're going to do is there's 3, 4, 5, 6, 7 points left. No, 8. I'm sorry, I forgot this one. So all I'm going to do is just draw the line. Remember, those 2 don't count. You shouldn't have. And just draw the line. But what trend do you see? What trend do you see? So positive, right? Positive. So the hours you spend studying is going to, your test grade is going to be affected by the hours you spend studying. Okay. Well, yeah. I mean, no, it doesn't matter. That's what I'm saying. Generally, you're not saying, oh, you can't say everybody that studies an hour is going to make an 80. Everybody that studies an hour and a half is going to make it 85. People are different. Their brains work differently. You read something differently. Everybody's different. But generally speaking, the more hours you study, the higher your grade's going to be. I mean, I had friends in school that I went to school with. They, in like history and science, or history and or science, they listened to the lecture. They did their work in class, never had to study, made hundreds on everything. You know people like that. They can just hear it and know it. Yeah. Okay, there's other people that can study 4 hours and make a 70. You see? So people are different. God made us all different. We're all better in some things than other things. And, so this is just generally speaking, we can say that in this case, the more hours they studied, the higher their grade. Yeah, that's all it's saying. Do you think that studying for 10 hours would greatly increase a student's grade?
No.
Not greatly, huh?
If you study for 4 hours and it went down to 3.
Yeah, 90. I mean, somebody studied for 3 and made 100. So, yeah. So I would say probably not, huh? What? Yeah. Well, some people can do that. See, that was better for me to study all the night before. I mean, not all night, but like, see, it's better for me to do that than study a little bit every day. What, Willie? Okay, look, there's no science to it. I know, I thought, oh, you got to count, no, you just look. There's 1, 2, 3, 4 points on that side and 4 on that side. You just try to make the line go in the middle of your data where there's the same number on each side. Sometimes I do better than others. But you're just trying to prove that the data, the points are going up. It's all you're proving right there. Okay? But I would say probably not greatly. Now, if they said, would it increase? Yes, but greatly increase? Probably not. Okay, look at 396. Okay, here's Old Faithful in Yellowstone National Park. Old Faithful. The scientists, what they did, she took this data, and she did the interval, that means between eruption. How long between eruption, and then how long they lasted after they erupted. Okay? So she found this data right here. Do you see an outlier? There. Oh, wait. There's clusters, aren't there? Look, circle that cluster of points and that cluster of points. And then there's this one that's outside everything, isn't it? So it's called, this is the outlier right here. And we're on C. Where's that point about? Tell me where you think. Oh, no. No, no, no. Look, guys. This is 50 and that's 60. 58, 3 I heard. Isn't it 58? Or 50, I mean, I wouldn't say 59. 59 be right on 60 almost. So about 58, 3? Is that a good point? Okay. So the rest of the data was pretty much clustered together. Okay? And we could draw a line, but wouldn't you think that, look, well, let's do the clusters first. What does this cluster go from what to what on the interval? 40 to 60, right? 40 to 60. And this cluster goes to from about what? That's 70. So 70 to 90. 70 to 90. Well, 90. No, that's 90. Well, yeah, maybe 95. We'll say 95. It doesn't have to be exact. Okay? But generally speaking, what can you say about what happened with the interval and the shorter the interval, what happened? The shorter the intervals, the longer?
The less.
Yeah, the shorter the length of the blast, right? I'm just going to put shorter blast. The longer the interval was between each one, what? The longer the blast. Okay? Does everybody get that? What's the no? What's wrong? Oh, I thought you meant. So, do you understand how we got that?
Yes, because.
Look, this cluster is low, like 2 to, 1.5 to 2.5. And this cluster is from 3 to 5. Okay, turn the page, or look at 397. So look at the top. This is a positive. So as x goes up, y goes up. So your line, look, when you draw, look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10. So what you're trying to do is get 5 on either side. And sometimes it's hard because they're points. See, a lot of those points made a line. Well, look at there. I just drew it and it come out. 1, 2, 3, and then 3 on that side. But you're showing that trend line shows that it's going up. And this one's negative. As x goes up, y is going to come down. Now, usually you say use positive and negative to mean good and bad. But negative doesn't mean it has to be a bad situation. Negative could mean that, okay, who knows about pitching? ERAs. Okay. Pitcher, y'all know what an ERA is? Earned run average. Okay. So the more strikeouts a pitcher has, the ERA is going to most likely go down. The team's not going to be able to score if they're not on base. Okay. Earned run average. That means how many runs the other team earned off of him. So as the more strikeouts he does, the lower his ERA. Okay? So it doesn't have to be a bad thing. It could be bad or good. It just means that as one goes up, the other information is going to come down. All right? The more hours you travel, the less distance you have to get home. Okay. Now, no association means, like we were talking about, your age and your number of pets. Okay. So let's look at Susan. She's gonna has a new product she's selling. Okay, what are you thinking? What's happening?
It's going down.
It's going down. It's negative. Everybody go circle it. Did they go on a line? Are they linear?
No.
No. But look, 1, 2, 3, 4, 5, 6. Be about like that, huh? It does show that it's coming down. It does show that it's coming down. And so it's negative. And let's look. If she sells her product for $2, how many people said they'd buy it? 20. Said yes, they'd buy it. All 20 said, yeah, I'll buy it. What about 8 people? I mean, if she charged $8, how many people said they'd buy it? About 13? Thank you. I have about 5 or 6 people that's not even paying attention to what we're doing. I asked at $8, how many people are going to say, yes, I'll buy it at $8? Kristen and Daniel and maybe one other person said 13. Does everybody see how they got 13 people? Yeah. Okay. So at $14, how many people you think is going to say yes, they buy it? I'd say no one. Okay, look at number 6. When I first read this, I thought, oh, your height has nothing to do with your reading level. They're comparing the reading level and your height. But look, here's an outlier, but what do you see about the other information? Well, not linear, but isn't it positive? So as the reading level went up, the height went up. Huh? What happened? As your reading level went up, why did you get taller? You get older, people. And as you get older, you should get smarter. And your reading level should go up, huh? The older you get, the taller you're going to get. Okay. So that's kind of, we put older, smarter. Which is taller. When you're older, you're going to be taller than you were at 5. Yeah. After I thought about it, I was like, oh, yeah, that makes sense. Okay, look on 398. On page 398. Now, remember what I told you about that first graph should have had a break in it? Look right here. That's what I meant. This should be 0, 0 every time. And what they did is they took a break and they took out part of the graph because they didn't need it, and they skipped to what? What point is that? Nope. 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 35, because they're counting by 5s, people. So that they skipped from 0 to 35 because they didn't have anybody that had 35 or below. Yeah, So what I need you to do is put these points from the table on the graph and answer number 2 and 3. 3 goes with this graph. So do 1 and 2 from that table and then number 3 from that graph. Go. I'm going to pause it, so please remind me to. Okay, on number 1, 6 is what? 45. 8 is 50. 10. 12. So about right there. And 14 is 60. About right there. Okay, so What's the association? Well, first, Isaac, we need to say positive. So first we need to say positive. Now, would you say this is basically linear? Look, nearly all the points are on the line. So that's what they were saying, basically linear. Almost linear. And then, what can you tell me about it? Older, taller. Or grew, though, the more he grew. Which,
It seemed like Henri got, like, whenever he got 12 and 14, slowed down.
Guys, you obviously weren't listening. I said I'm recording. Y'all tell on yourself all the time. I wasn't listening. Okay. Yeah, Daniel, explain. They interrupted you.
Like, whenever he got 12 and 14, like, he only grew about 6.
He slowed down, didn't he? But right here, he grew what? 5, a little more than 5, and then slowed down. Very good. I'm glad you looked at that. Okay, number 3. Are there any clusters?
Yes.
2 clusters. And then there's an outlier, isn't there? Let's go ahead and write the outlier down here. 35, 17, or 18? Yeah. Good job. Okay, so the first cluster is what?
5.
Yeah, well, 5 is here, so maybe 7 to 15 or 14.
Yes.
And then the next cluster that's 15, so there you go. Exactly what the book said. All right, does everybody get that? Okay, look on 399. Look at the long jump in the Olympics. Look at what happened. It said on number 5, describe the association between 1960 and 1988, which is right. This is the last one. So what would you notice about those points? But not linear, huh? No. Pretty far off from linear. But it's positive between those. But what do you see sticking way up there on 1968? Man, in 1968, there was somebody that was just like off the chart, way better than anybody else. I mean, it was just like a miracle person. Because normally the points, well, I don't know. We could look it up, couldn't we? We could Google and see who won the long jump in 1968. Okay? But he was way above average up here. Okay? Then from on 6, it says after 1988. Well, they're coming down, aren't they? But what happened in between those years? They kind of went up, huh? Yeah, looks. Well, they basically all came down. But these 3 years, it went up a little bit. But then it came way down. So, it's basically negative. Okay. Are there any questions about scatterplots? Pretty easy, huh? So you understand about a trend line? How do you draw the trend line? Yeah, but the trend line, yeah, you have to kind of put it in the middle of the data of the point so you have the equal amounts on either side. Okay, if it's going up, it's positive. If it's coming down, it's negative. If they're all over the place, no association. Very good. Have a good evening.